In this video, we'll explain how ROOK delivers data and what you need to successfully receive it. In ROOK, webhooks are used to instantly notify clients when an event is logged or a summary is generated in any connected data source. Our main focus is to optimize data delivery, ensuring that customers are quickly informed through our data channels as soon as new data becomes available. This process enables real-time synchronization between data sources, ROOK, and clients, eliminating the need for constant pulling or manual monitoring. We recommend implementing the following workflow when handling webhook events. 1. Receive the payload. Your endpoint receives the webhook payload sent by ROOK. 2. Validate the authenticity of the request using HMAC. This step ensures that the request was sent by ROOK and has not been tampered with. Please note that HMAC validation is optional and becomes available once your account is activated in production. To learn more about how to implement this validation, please refer to our HMAC tutorial video. 3. Log the request for traceability. Store relevant request information such as timestamps, headers, and payload data. This helps with debugging, monitoring, and auditing webhook deliveries. 4. Respond with HTTP 200. Return an HTTP 200 status code as soon as the webhook is received and validated to acknowledge successful delivery. You must return a 200, 201, or 202 status code to let ROOK know that you successfully received the data. If any other status code is returned, for example, 500, 401, etc., ROOK will initiate a retry process to resend the data. Failed deliveries trigger retries at the following intervals: 2 hours, 24 hours, and 48 hours. 5. Process the payload asynchronously. Instead of processing the data immediately, enqueue the payload so it can be processed and stored asynchronously. This helps ensure your webhook endpoint responds quickly and avoids timeouts. Now that we have explained the webhook processing flow, let's review the recommended backend architecture that your system should implement to handle webhook deliveries reliably. In general, your webhook infrastructure should include the following components: an HTTP endpoint where ROOK will send webhook events, a queuing mechanism to enqueue incoming payloads for asynchronous processing, processing queues capable of handling large volumes of incoming webhook events, a retry mechanism to handle failed storage or processing attempts. This approach ensures that webhook deliveries are handled reliably, scalably, and without blocking the initial request. Let's walk through an example implementation using AWS services and explain the role of each component. API Gateway exposes the public HTTP endpoint that receives webhook requests from ROOK and forwards them to the webhook Lambda. Webhook Lambda validates the incoming payload, enqueues it into Amazon SQS, and immediately returns an HTTP 200 response to API Gateway once the payload has been successfully queued. Amazon's Simple Queue Service, SQS, buffers incoming payloads and allows the system to process them asynchronously, decoupling the ingestion layer from the processing layer. Dead Letter Queue, DLQ, captures messages that fail to be processed successfully, allowing them to be inspected or retried later. Storage Lambda, triggered asynchronously by SQS to process each message and persist the data into the database. Amazon CloudWatch provides centralized logging and monitoring for observability, debugging, and operational insights. In your portal, you'll need to configure your webhook URL. At first, if you don't have a ready-to-use webhook, you can use webhook.site to create a temporary endpoint and test how the incoming data will look when received. Now, we'll walk through a simple webhook implementation that follows the recommended architecture and processing flow using AWS services. As you can see in the code, the webhook is implemented as an AWS Lambda function that handles incoming webhook events. Let's briefly go through what each part of the code is doing. First, the Lambda function receives the event, which contains the webhook payload sent by ROOK. For traceability purposes, we log that a new payload has been received. After that, HMAC validation can be performed to verify the authenticity of the request. Next, we retrieve the request body from the event. If the body is missing, the function immediately returns an HTTP 400 response, indicating that the request is invalid. Once the body is available, you can log the body content. Logging this information helps with monitoring and debugging webhook deliveries. Then, it is sent to Amazon SQS, where it will be queued for asynchronous processing. After successfully enqueuing the payload, we log this action again to maintain traceability and ensure that the event was properly queued. Finally, the webhook responds to ROOK with an HTTP 200 status code, acknowledging that the payload was successfully received and queued. If any unexpected error occurs during the process, the function returns an HTTP 500 response, indicating that the webhook could not process the request. Now, let's test our webhook implementation. As we can see here, we have a user connected to Garmin. Next, we synchronize the data from the wearable using the Garmin application. We're using Garmin for this example because whenever Garmin detects that new data has been synchronized in the app, it sends that data to ROOK via webhook. This allows our example to work much faster, since as soon as we synchronize the wearable data in the Garmin app, the data is sent to ROOK, and ROOK immediately forwards it to our webhook. In the ROOK portal logs, we can see that updates for the summaries have already been sent to our webhook. Even though the webhook was received today, the summary date corresponds to a previous day. By checking the document version, we can identify whether this payload represents an update to an existing record or a new one. If we now look at CloudWatch, we can observe that several payloads were received from ROOK. Let's select one of them at random. Here we can see the traceability of our webhook process. When a new event was received, the content of the payload, and when a payload was successfully sent to Amazon SQS for asynchronous processing. This logging allows us to easily track the lifecycle of each webhook event and verify that the system is working as expected. And that's how you can implement a scalable webhook architecture to receive and process data from ROOK. We'll see you in the next video. Thank you.